Our universe is really big and really old. Even though it began with a bang, it's getting pretty chill these days. But how did it begin and where is it going? Well, if we want to find out where something's going, the best thing to do is to look back in time. So grab your cosmic sea legs, because we're retaking a tour through space and time to find out how the universe began and where it might be ending. We can use telescopes to look back in time because light takes time to travel, and the farther away we look, the farther back in time we're seeing. If we observe a galaxy that's 46 billion light-years away, we're actually seeing it as it was 46 billion years ago. By looking into deep space, we're literally peering into the past. And when we do this, we can see some amazing things like the formation of the first galaxies and the birth of the first stars. We can also look back to see the conditions of the universe right after the Big Bang, which is great because that's right around the time we think everything began. About 13.8 billion years ago, the entire universe and all matter within it was concentrated into an area smaller than an atom. Then it exploded outward in a cataclysmic event known as the Big Bang. And that explosion wasn't just big, it was the biggest explosion ever, which might make you wonder, what happened before the Big Bang? Well, to answer that question, we'd have to know how the universe began. And scientists don't have all the details yet. Some theories suggest that the Big Bang may have been caused by quantum fluctuations, or perhaps there was a massive amount of energy in a tiny space that suddenly released itself. But that's speculation. All we really know for certain is that the Big Bang is the defining event of our existence. It's what kicked off the cosmic chain reaction that led to galaxies, stars, planets, and eventually life as we know it. And one of the things that scientists have been able to learn is that many of the building blocks of the universe were created not long after the Big Bang. For example, the hydrogen atoms that make up water weren't around before the Big Bang, because there was no universe for them to exist in. They were forged in the fires of the early universe and have been around ever since. Of course, that doesn't mean they've always been in the same place. As the universe evolved, these hydrogen atoms have moved around and formed new bonds with other atoms, but they're still here. In fact, the Big Bang theory predicts that most of the universe is made of hydrogen and helium, along with trace amounts of lithium. And observations of distant stars and nebulas confirm this prediction. So when we look back into deep space, we're not only seeing the beginning of the universe, but we're also seeing the beginning of these elements. Of course, this view of the universe's beginnings isn't complete without considering gravity. When the universe began, every point in space had the same temperature and density. But gravity causes matter to clump together. And even though everything started out pretty evenly distributed, over billions of years, gravity has caused more and more matter to accumulate in some places rather than others. This is why we don't live in a universe filled with perfectly round blobs of matter. Instead, we live in a universe full of galaxies, stars and planets, all of which are irregular in shape. It's easy to get caught up in our own little patch of space and forget that our solar system is just one tiny corner of the Milky Way. But it's mind-boggling to imagine that everything we see extends infinitely in all directions. But there's one thing that seems to contradict this idea. As we look out into the universe, we see that it's expanding. That means regions that were once close together are now being pulled apart at tremendous speeds. And the farther away a galaxy is, the faster it's moving away from us. At first glance, this would seem to suggest that the universe is getting bigger, but it really isn't. The distances between galaxies are increasing, but that doesn't mean the galaxies themselves are growing. The universe is the same size as it was the moment it began. It's just that everything is moving away from everything else. And that brings us to another piece of the puzzle, the age of the universe. Scientists estimate that the universe is 13.8 billion years old, give or take a few million years. And that means the entire universe has been expanding for 13.8 billion years. If the universe began with the Big Bang and has been expanding ever since, then it should be much larger now than it was back then. But that doesn't seem to be the case. In fact, observations suggest that the universe has been expanding at a steady rate for billions of years, which raises a question. If the universe is getting bigger, then why doesn't it feel like it? Well, the answer lies in the way the universe is expanding. The fabric of space itself is stretching, carrying galaxies along for the ride. But at the smaller scales of galaxies and stars, the effects of gravity are much more significant than the effects of this large-scale expansion. So even though the universe may be expanding, it feels like everything is staying in place. In fact, our solar system is flying through space at a speed of about 250 kilometers per second, and the Milky Way is orbiting the center of the galaxy at a speed of about 250 kilometers per second. At those speeds, you wouldn't notice any difference. So if the universe is expanding, why does it feel like everything is staying in place? Well, the answer lies in the way the universe is expanding. The fabric of space itself is stretching, carrying galaxies along for the ride. But at the smaller scales of galaxies and stars, the effects of gravity are much more significant than the effects of this large-scale expansion. So even though the universe may be expanding, it feels like everything is staying in place. In fact, our solar system is flying through space at a speed of about 250 kilometers per second, and the Milky Way is orbiting the center of the galaxy at a speed of about 250 kilometers per second. At those speeds, you wouldn't notice any difference. So the expansion of the universe is happening everywhere, but it's not uniform. Some parts of the universe are expanding faster than others, which creates a sort of lumpy structure on smaller scales. But when we zoom out far enough, the universe looks pretty flat, and that's a bit of a problem, because according to the laws of physics, the universe should be curved like a sphere. That means, if you traveled far enough in any direction, you'd eventually end up back where you started. But we haven't found any evidence of this. No matter how far we look, we don't see any signs of a closed universe, and it's not just spheres. The universe could also be shaped like a saddle. This would mean that parallel lines would eventually diverge, and the universe would become increasingly open. Again, we don't see any evidence of this. So despite the fact that the universe appears lumpy at smaller scales, it's relatively flat on a larger scale. And that presents a bit of a mystery. According to the laws of physics, the universe should be curved, but observations say it's flat. There are a few theories about why this might be the case. One idea is that the universe is actually infinite, which would explain why it's flat. But that's just a guess. The real reason for this flatness could be related to the rapid expansion of the universe. After the Big Bang, the universe expanded faster than the speed of light, which is normally impossible. But that period of rapid expansion, known as inflation, could have smoothed out the universe, making it flat. That would also explain why we don't see any evidence of the universe's beginning. If the universe expanded faster than the speed of light in the moments after the Big Bang, then light wouldn't have had time to reach us, leaving us in the dark about the universe's beginnings. It's fascinating to look back into deep space and see the beginnings of galaxies and stars. It gives us a sense of perspective about our place in the universe, but it also makes us realize how much we don't know. We've come a long way in understanding the universe, but we're still in the dark about many things. From the smallest particles to the largest galaxies, there's still so much we don't know. But as we continue to explore the universe, we'll continue to learn more about its origins and its ultimate fate. Maybe one day we'll be able to answer the question of where it all began and where it's all going. Until then, we can marvel at the beauty and complexity of the universe and our place within it. So the next time you look up at the night sky, remember that you're seeing a tiny snapshot of the entire universe. You're re-seeing the stars and galaxies as they were in the past, and you're re-seeing the building blocks of the universe as they were forged in the fires of creation. Thanks for watching this episode. If you want to help us explore the universe, you can join our community on a crowdfunding platform. With your support, we can continue to make videos that explore the wonders of the cosmos. Click below to learn more.